in the industry. And as we go through them, we'll see some tabulated what to check and what to do about it for each of the points listed here. So we're going to cover high pressure on the discharge, low pressure on the discharge, low pressure on the suction line, high pressure on the suction line, some general electrical issues you might come across, as well as other issues. Now, before we jump into it, I just want to warn you that chillers are very expensive and they can be quite dangerous. So if you are not competent or you're not authorized to work on them in your building or your client's building, then please do not seek professional advice instead. Another point to note is that on the display unit of the chillers or on the BMS units, there will usually be an error code displayed on there. If you take this and then check with the manufacturer, they will usually have a maintenance program or a guide that you can download. So have a look through this and see what the error code is first. That will probably solve it a lot quicker. But to give you a general idea of type of faults and how to troubleshoot them generally with a chiller, then let's jump into it and have a look at these. So as you can see, I've just listed with the high pressure discharge and with all the points going forward, just what to check and what to do about each of them. So if you need to skip through and check the rest, then please do so. Otherwise, stay with us and we'll just start to go through them. So on the left, you'll see I've listed it what to check. So these are common problems which will cause high pressure discharge. And on the right hand side, there's some reasoning there for what to check and what might be causing this a bit more as well. So you can see at the top there, we've got fouling, and that is a build-up in minerals on the condenser tube. Now this is very common in water-cooled chillers especially, and it's always caused by bad water treatment regimes. So you want to make sure that this is a top priority on your system in your buildings, and advise your clients, etc., to make sure they do this. Because basically, especially when you have open cooling towers, what's going to happen is all the minerals and the dirt that's absorbed from the air will be absorbed into the condenser water, and that will then flow around the system, and it will begin to clog the pipes and also around the tubes of the heat exchanger. So it basically starts to insulate the heat exchanger in the condenser, so you can't transfer all the unwanted heat. So you need to make sure that this is a top priority at your site. And on the flip side, you're also going to have with air-cooled chillers, you're going to have dirty condensers. So over time, especially when there's been a bit of rain or something like this, and there's a bit of dirt kicking up in the rain or up on the roof, then the air-cooled chiller condensers are going to get blocked as well. So you want to make sure that all the tubes and fins are cleaned regularly, but remember that the tubes out there are full of refrigerant and they are very delicate, so be very careful when you do these. Use light brushes and also some comb fins as well. Another common issue, especially with air-cooled chillers, is a reduction of airflow over the condenser, and that's usually where some debris has blocked part of across the fins or some of the fans, and so not enough air is actually flowing through the condenser to take all the unwanted heat away. It could also be that one of the fans has stopped working or is behaving erratically, so you want to go up there and just visually check that they're clean, it's free from obstructions, and that the fans are all working. So you might also suffer a high pressure discharge with a reduction of water flow through the condenser. So for that, you want to just check all the valves and the strainers and also the pumps to make sure they're all working and they're all flowing, passing the correct flow rate through that they should do. And if you need to check this and you don't know what the values are of what the flow rate should be, then you want to look at the commissioning data, which was when the chillers were installed. They would have been commissioned, or they should have been commissioned, and through there it will tell you what the flow rate of water should be into the chiller through certain points through the pipework. Another problem which will cause your chiller to trip on high pressure is when the return condenser water on a water-cooled chiller is returning from the cooling tower and it's too hot. This is also going to lead to the pressure build-up. So for that, you want to go up to the cooling towers and you want to make sure that the fans are working, that the cooling tower bypass valves are properly aligned, and that the water isn't just leaving the chiller, going up to the cooling towers. It's not actually passing through the cooling towers, or it's dumping back round, and that water is then returning straight back to the chiller without actually reducing any heat from it. Now it could also be that the discharge shut-off valve is partially closed. It's slightly uncommon for this to happen, but it could be knocked or some controls have been on there. So do check that as well. With the air-cooled chillers, it could be that the ambient air conditions, the air temperature is above the condenser capabilities, so it simply can't work in these conditions. You have to wait for it to cool down or adjust the parameters and the set points of the chiller. Also make sure you check with the manufacturer that it's capable of doing so before doing that. Another fairly common issue with it is that the chiller has been overcharged with refrigerant. So obviously you want to go around and check all your pressures and your temperatures and sight glasses around there. And it could also be that a non-condensable material or fluid has entered into the refrigerant loop. So you want to go around and check this as well. And if you do suspect that it's because of this, then you want to obviously purge that out. And of course, if you've checked all these and nothing seems to be the problem, then it's likely going to be that you've got a faulty pressure switch. So you want to check that, swap that out with another one if you can, and test that. Alright, so moving on to the low pressure discharge. Now some things are listed here obviously which might cause that. So the suction valve might be partially closed. So do check that. It's fairly uncommon, but it could happen. So have a check of that. Now on the flip side of the high pressure discharge, we've also with the overcharged refrigerant, then if you imagine if there's less refrigerant in there, or it's undercharged, then you're going to have a low pressure discharge. So same for with the previous section where you want to just check that the refrigerant has enough charge in the system, and if you suspect that this is the problem, then you need to top it up. Another issue could be that the ambient air temperature is just too low. Your chiller, your air-cooled chillers will not be able to operate in these conditions, and there's not so much you can do about that. You really have to reprogram the system and check with the manufacturers that this is possible to do. Another common issue with this will be a low suction pressure, and we're going to have a look at that in just a moment as well in the next slide. And then probably of this list, the most common issue with that is going to be the dirty or obstructed evaporator. So you just want to check the evaporator tubes, make sure they're fairly clean, or as close as you can get it, and consider cleaning this. So you just want to make sure that there's maximum heat transfer capability available as possible. Otherwise, you're just going to waste energy. Now coming on to the low pressure on the suction side, some reasons that this could occur. Again, this could be down to a low refrigerant charge, so you want to check around your system for this and top up if needed. Don't forget to check for leaks as well, because the refrigerant that's if it's low, then it's got to have gone somewhere. So check around the system, make sure that's not leaking. One of the more common issues with this is going to be a blocked expansion valve. So you might have to clean this and or replace it if needed, and there's a couple of items there of how to check for this. It could also be that there's a reduction of flow of water into the evaporator. So again, you want to check all the valves and the bypass valves, etc., and the pumps for this to make sure they're all working and they are where they should be. Again, if you don't know what the flow rate of water should be through that chiller or the evaporator, then you want to check your commissioning data. That will state all the values in there, at least from when it was first installed and commissioned. You also want to check that the filter dryer and the strainer, if they're obstructed or clean, and then just clean these or replace them if you need be. And this could also be caused by the condenser water temperature being too low, so you want to have a look at the set points and the design criteria for that. And then you might have to adjust the bypass valves, etc., for this around the cooling towers to make sure that the water is coming back at the correct temperature. Now if you've got high pressure on the suction line, then there's kind of three things that can cause this. Excessive load is probably the main one, and that is where the cooling load is just too much for the chiller to handle. So you want to reduce that if possible, or spread this over to other chillers and cooling equipment. And it's also quite likely that the expansion valve is overfeeding refrigerant as it's starting to break down. So you want to check this as well. If this happens, then you probably have to replace the expansion valve. But obviously do try to adjust the superheat set point first. And then again, as previously mentioned, it could also be overcharged with refrigerant. So you want to check your set points and temperatures and pressures around the system. And then if that is the cause of it, then you want to reduce the refrigerant in there to remove some of the excess refrigerant. Now coming on to electrical issues. These are some of the more common issues, electrical issues that you're going to find with chillers. So an unbalanced voltage supply to the chiller. So you want to measure your voltages on each of your phases to make sure that they're actually balanced. And it could indicate that there's a problem with the electrical switchgear within your building. Or if you haven't quite got this stuff, then you want to speak to the electrical supplier to call them out and they'll come and check it. Now, a more common problem with the chillers is that you can have a fluctuating voltage or current, and that's usually going to be affected by other equipment which is connected onto the same circuit as the chillers, and that's going to cause fluctuations or distortions in the voltage and current waveforms. And it's possible that your chiller will pick up on this, see that there's a distortion in there, and it will shut the chiller down as precaution. So if you get a sudden inrush current to another plant item on the same circuit, then it's likely it could trip your chillers. Another thing is going to be loose cables or wires. This gets more common after a shutdown, and there's been a lot of work done on the chillers that maybe some things have been unscrewed and haven't quite gone back into as tight as they should do. And this can make the chiller behave quite erratically. One of the easiest ways to check this is just to go around all the connections with a thermal imaging camera, and if you see that some of the screws and the connections are quite warm, then you know that there's going to be a loose connection there. Another fairly common cause of this is going to be a blown through fuse or an open breaker. So you want to just go around, check the fuses and the breakers on your LV panels to make sure that these are all working and not open. And obviously you want to check before you turn this back on for any grounding faults or errors. And obviously before you turn any breakers back on, you want to make sure that no one's working on the machine and that the equipment has not been isolated for safety reasons. So speak with your authorized person before doing so. Another issue which is slightly less common but possible is that you've got a phase loss. So if you've got a three-phase supply to the chiller, then one of the phases has been lost or broken or disconnected, etc. So do check that, because obviously the chiller will not start unless it's got proper electrical supply to it. And it could also be that there's been a ground fault in the motor, and the chiller has detected this and just for safety reasons shut itself off. So you want to check the motor for this. You may need a specialist to come in and do so. But if there is a grounding fault on the chiller motor, then do not turn it on, because this is going to be very expensive to replace if it goes wrong. There's a few other fairly common items listed here as well, which could cause the chiller to go into fault. One of them being the thermal overload for the motor. So if the temperature within the motor casing gets too high, then the motor will send a signal and the chiller will just cut out to protect itself, and you will not be able to turn the chiller back on while that temperature is still above the threshold. And that could be that there's just too much load on the chiller, or the cooling mechanism for that has been blocked or reduced, so you want to check that as well. Now, one of the more fairly common issues with this is going to be the flow sensor is broken, especially if you've got one of the paddles type sensors. So before a chiller will turn on, it has to check that there is sufficient flow going through the evaporator and the condenser if you've got a water-cooled chiller. And if it detects that there is not enough flow in there through the paddles, there's different ways that it can do it, but if it detects there's not enough flow, then it will not start the chiller to protect itself, to stop the evaporator from freezing over. But equally, during its operation, if the paddle or the sensor, which is detecting the flow of water, loses communications or develops a fault, so it's no longer measuring or sending the signal back to the control unit, then the chiller will assume that there is no flow or not enough flow, and it will disconnect itself from the system. So the chiller will just turn itself off and will not start again until there is sufficient flow. Another safety feature that is built in is the compressor hourly starts lockout. So typically chillers will only be allowed to start, this is set by the manufacturer, so they'll only be able to start up a certain amount of times per hour. So if you've got very low loading on the chiller and it's turning off and then back on when it reaches the set point again, it will only be allowed to start again so many times per hour. And this is to protect itself and also all your electrical equipment, as the inrush current for these chillers can be very large, and large enough that it will damage your electrical equipment and distribution for your building, as well as the chiller motoring or motor winding. So if you've got a low loading and your chiller is not turning back on, then this is likely the reason why. Now, all the items listed here, then it's not a complete list. Obviously, there are hundreds of things that could be going wrong with the chiller or issues you're facing. But these are some of the more common versions, or common issues even. But one of the easiest ways to resolve any of these is to check what the error code is and look it up with the manufacturer. Also, again, make sure you're authorized and competent enough to work on these chillers, as they are expensive and quite dangerous to work with. And where possible, try to get a service engineer from the manufacturer to come in and do your servicing for you. But anyway, that's it for this video. I hope you've liked and enjoyed this, and it's helped you. Please don't forget to like, subscribe and share, and if you have any questions, then leave them in the comments section below. Also check out our website, theengineeringmindset.com. And once again, thanks for watching.